Hi, welcome to Vision Mathematics. My name is Thomas Landa and I'm going to take you through the lesson on this video. In this lesson number 3 on grade 12 trigonometry, we'll be looking at how to use the compound angle formula in reverse. Enjoy your lesson. Lesson number 3. Compound angle formulae in reverse. I will begin by outlining a general approach. Firstly, if the expression you are dealing with has angles which are not acute angles, use reduction formula to reduce all angles to acute angles. That is, all the angles must lie between 0 degrees and 90 degrees. Secondly, ensure that there are only two angles. Remember, the compound angle formulas are in the form sine alpha cos beta, cos alpha sine beta, or cos alpha cos beta, sine alpha, sine beta. They deal with only two angles. So if the expression that you are dealing with, after reducing all angles to acute angles, you still have 3 or more different angles, try to use co-angles to reduce them to only 2 angles. 3. Ensure that the order in which sine and cosine appear in the expression you are dealing with corresponds with the formula. Refer closely to your information sheet. If it is not, you may have to adjust to make them correspond before you can proceed. Lastly but not least, ensure that the first term is positive. If it is not positive, you factor out -1 to make sure it is positive, because all our formulae start with a positive term. Let's have a look at an example. Express as the sine or cosine of a single angle, cos 108 degrees, cos 188 degrees, plus sine 252 degrees, sine 172 degrees. Now in this expression, all the angles are not acute. So the first step is to reduce all these angles to acute angles using reduction formula. 108 degrees lies in the second quadrant. In the second quadrant, cosine is negative, so we have minus here. And this reduces to cos 72 degrees, which you find by simply subtracting 108 from 180, the boundary of the second quadrant. Then coming to 188 degrees, this falls in the third quadrant. Again, in the third quadrant, cosine is negative. So this reduces to cos 8 degrees, which you find by simply subtracting 180 from 188. 252 degrees lies in the third quadrant. In the third quadrant, sine is negative. Then this reduces to sine 72 degrees, which you find by subtracting 180 from 252 degrees. And finally, 172 degrees. This one lies in the second quadrant. In the second quadrant, sine is positive. And subtracting 172 from 180, we get 8 degrees. Then multiplying out the brackets, a negative number multiplied by a negative number will give us a positive. So here we have cos 72 degrees, cos 8 degrees. Here it's a negative number multiplied by a positive number. It will give us a negative. Minus 72 degrees, sine 8 degrees. Now we have to compare this closely with the formula given in the information sheet. Look at the order. The cos, sine, sine. If they correspond, then you choose the correct formula. And remember that the cosine one, the one which is cos, cos, it's for the cosine. It is the one which, when you have a minus on one side, the other side will have a plus. But the formula sheet will show you that. So this simplifies to cos 72 degrees plus 8 degrees, which is cos 80 degrees. Refer back to the question to see that you have done what you are required to do. It says express as the sine or cosine of a single angle. This is the cosine of a single angle. So we are done. Example number 2. Evaluate without the use of a calculator. Cos 45 degrees, sine 75 degrees, plus sine 135 degrees, sine 15 degrees. Now, looking closely at the expression, we observe that 135 degrees is not an acute angle. So we deal with this one first. Sine 135 degrees. 135 lies in the second quadrant. In the second quadrant, sine is positive. So this reduces to sine 45 degrees. 45 degrees is 180 minus 135. Then we look at the angles again. We observe that there are 3 different angles: 45 degrees, 75 degrees, and 15 degrees. We must reduce them to 2. Now we can see that 75 and 15 are co-angles. They add up to 90. Observe that although 45 and 45 are co-angles, they don't help us because it's the same number. So we either reduce or convert sine 75 to cos 15 or sine 15 to cos 75. I choose to reduce sine 75 to cos 15, so that we have cos 45 degrees, cos 15 degrees, plus sine 45 degrees, sine 15 degrees. Then we check the order in which sine and cosine come. It's cosine, cosine, sine, sine, which agrees with the formula that we want to use. So this reduces to cos 45 degrees minus 15 degrees. Remember, the compound angle formula for cosine is the one where if you have a plus sign on one side, the other side will have a minus sign. But refer closely to your formula sheet. Then that simplifies to cos 30 degrees. And its value is square root of 3 over 2. Practice questions. At this point, you can pause the video and attempt the questions before you look at the suggested solutions. Question number 1. Sine 10 degrees cos 50 degrees plus cos 10 degrees sine 50 degrees. Looking at the angles, we see that all of them are acute. So we proceed to check the order in which sine and cosine come. That's sine, cos, cos, sine. Now this corresponds with the order in which they come in the compound angle formula for sine. So this is direct application of the formula. This is equal to sine 10 degrees plus 50 degrees, which gives us sine 60 degrees. And its value is square root of 3 over 2. Question number 2. Cos 50 degrees, cos 140 degrees, minus sine 130 degrees, sine 220 degrees. Now in this expression, 3 of the angles are not acute, so we must deal with these first. So that's equal to cos 50. Now 140 degrees is in the second quadrant. In the second quadrant, cosine is negative, and that reduces to cos 40, which is 180 minus 140. Then minus. Observe that this sign here is the one which is here, and we are yet to deal with 130 degrees. 130 degrees is in the second quadrant. In the second quadrant, sign is positive. Observe that this minus sign here is this one, but sign is positive in the second quadrant, so it comes down as it is, but this sign remains where it is. So that reduces to sine 50 degrees, which is 180 minus 130. Then sine 220. 220 is in the third quadrant. In the third quadrant, sine is negative. And subtracting 180 from 220, that reduces to sine 40 degrees. Now multiplying out the brackets. A positive multiplied by a negative, that gives us minus cos 50 degrees cos 40 degrees. Plus, when we multiply out the negative, minus sine 50 multiplied by minus sine 40, it will give us a positive sine 50 degrees sine 40 degrees. Now let's check the order in which the functions come. It's cos, cos, sine, sine, which agrees with the order in which they come in the compound angle formula for cosine. But our problem is the first term here is negative. It shouldn't be. So we have to factor out minus 1 to make this positive. So factoring out minus 1, remember we don't have to write the 1 because it doesn't change anything. So factoring out minus 1, it will make this one which remains in the bracket positive. It will change this one because that's a positive number divided by a negative number. It will give us a negative. So factoring out minus 1 will change all the signs inside the bracket. So that will become minus sine 50 cos 40 degrees. Then applying the compound angle formula for cosine, which we remember that if you have a minus on one side, the other side will have plus. So that will be cosine 50 degrees plus 40 degrees, which reduces to the cosine of 90 degrees. Now 90 degrees is a special angle, and if you know its value, that's equal to 0. If you don't know it, you can sketch the graph. You can use your calculator, although the question doesn't want you to use the calculator, because at this final step, if you use your calculator, write 0, nobody will ever know that you use a calculator. Question number 3. Cos 28 degrees cos 2 degrees minus sine 28 degrees sine 2 degrees. Now this seems to be straightforward. Cos, cos, sine, sine, and you have two acute angles, 28 and 2. 28 and 2. So looking at your formula sheet, you will see that this is the right hand side of the compound angle formula for cosine. So on the other side we will have a plus sign. So that is equal to cos 28 degrees plus 2, which is equal to cos 30 degrees, which is equal to root 3 over 2. Question number 4. Sine 70 degrees cos 10 degrees minus cos 80 degrees cos 70 degrees. Now looking closely at the expression, we see that they are all acute angles. But then we have 3 angles. We need only 2. So we must reduce one of them using co-angles. We observe that 10 and 80 add up to 90. They are co-angles. And remember, for co-angles, the sine of one is equal to the cosine of the other one. So cos 10 can be replaced with sine 80. Or you can replace cos 80 with sine 10. I choose to replace this one to make the numbers smaller. So that's sine 70 degrees cos 10 degrees, which is that. Then reducing this one using co-angles, this will be equal to sine 10 degrees, a co-angle of 80 degrees. 80 plus 10 is 90. So cos 70, cos 70. Then we check the order in which the sine and cosine come in the expression. That's sine, cos, sine, cos. Now that is not the order for the compound angle formula for sine. The order should be sine, cos, cos, sine. So we'll interchange here cosine and sine. Remember, multiplication is commutative. In other words, the order in which you multiply two numbers does not affect the result. So sine 70 cos 10, here we swap cos 70 and sine 10, so that the order is now correct. Sine 70 cos 10, cos 70 sine 10. And remember, for the compound angle formula for sine, the sine which is on one side is the sine which is on the other side. So this is going to be sine 70 degrees minus 10 degrees. And simplifying, this is equal to sine 60 degrees, a special angle. And its value is √3/2. Question number 5. Sine 440 degrees cos 310 degrees plus cos 110 degrees sine 50 degrees. Now in this expression, we observe that three of the angles are not acute, so we must deal with those first. The first one, 440 degrees, exceeds the period of the sine function, which is 360. So we begin by subtracting 360 from 440 to see what happens. So 440 minus 360 gives us 80, which is an acute angle. So we are done with that one. 310 lies in the fourth quadrant. In the fourth quadrant, cosine is positive. So this reduces to cos 50, which is 360 minus 310. Plus 100 is in the second quadrant. In the second quadrant, cosine is negative. So that reduces to cos 80 degrees, which is 180 minus 100. Then sine 50 is fine. Then here a positive and a negative will make a negative. And let's now check the order. Sine, cos, cos, sine, which is the correct order for the compound angle formula for sine. So that reduces to sine 80 degrees minus 50 degrees, which gives us sine 30 degrees. And the value is half. Well, that marks the end of today's lesson. Meet you in lesson number 4.